Good morning students, I am Moshmi Prashad and creator of this channel Digital Generation. This channel is regarding chapter wise preparation for both ICSE and CBSE students. I hope you will get best knowledge and explanation from this channel. Today we are going to study about plaster of Paris. The chemical name of plaster of Paris is calcium sulfate hemihydrate CaSO4 half H2O. The name plaster of Paris is derived from the fact that it was prepared by heating gypsum which was available abundantly in Paris. And this plaster of Paris was used in a massive way for construction buildings. In short, plaster of Paris is also known as POP. Preparation of plaster of Paris. Plaster of Paris is prepared by heating gypsum which is called calcium sulfate dihydrate CaSO4 2H2O at a temperature of 100 degrees centigrade in a kiln. When few crystals of gypsum is taken in a kiln and is heated at 100 degrees centigrade, then calcium sulfate dihydrate loses its 3/4 of its water of crystallization and forms plaster of Paris. Now let's see the reaction. This is gypsum or calcium sulfate dihydrate. When it is heated at 100 degrees centigrade or 373 degree Kelvin in a kiln, then this gypsum gives 3/4 of its water of crystallization and forms calcium sulfate hemihydrate which is plaster of Paris. And this is water of crystallization which is given off. Now for preparing plaster of Paris from gypsum, the temperature should be maintained very properly and carefully, because if calcium sulfate dihydrate or gypsum is heated above 100 degrees centigrade, then this gypsum or calcium sulfate dihydrate will give off its two molecules of water of crystallization and will form anhydrous calcium sulfate. This anhydrous calcium sulfate is known as dead burn plaster. This dead burn plaster is useless because it does not set like plaster of Paris when water is added to it. So this becomes useless. So temperature of heating gypsum should be maintained very carefully and properly. It should not exceed 100 degrees centigrade. Now here it is clear that half molecule of water of crystallization is present in one formula unit of calcium sulfate. From here, it is clear that half molecule of water of crystallization is present in one formula unit of calcium sulfate. As half molecule of water is very difficult to write, so we can say that one molecule of water of crystallization will be present in two molecules of calcium sulfate. So we can write this CaSO4 half H2O in this way also, CaSO4 H2O. So the formula of plaster of Paris is CaSO4 half H2O or 2 CaSO4 H2O. These two are same. Now if we multiply this equation with 2, we will get this CaSO4 H2O, which is also plaster of Paris, because it is very difficult to get half molecule of water of crystallization and it is very difficult to write also. So we make it in whole number. 2 CaSO4 2H2O, then heated at 100 degree centigrade or 373 degree Kelvin in a kiln, then it will give CaSO4. It is multiplied by 2 CaSO4 H2O. This is also plaster of Paris and this is also plaster of Paris. It is just multiplied by 2 to make it easier. Plus 3H2O. Here 3H2O because 3 by 2 H2O is given out. 3 by 2 into 2 H2O will give 3H2O. So this is the formula of plaster of Paris. Now we will study about the properties of plaster of Paris. Plaster of Paris is a white color powder. The most remarkable property of plaster of Paris is setting into a hard mass on wetting with water. Wetting is WETTING. So when water is added in plaster of Paris, it sets into a hard mass. This setting of plaster of Paris into hard mass is due to its hydration to form gypsum or CaSO4 2H2O. The setting of plaster of Paris into hard mass is accompanied by slight expansion of volume, and due to this reason, plaster of Paris is used for making casts for toys and statues. Plaster of Paris is also used in dentistry. Plaster of Paris is always stored in moisture-proof container because presence of moisture can cause slow setting of plaster of Paris and bringing about its hydration to form gypsum CaSO4 2H2O. This slow setting of plaster of Paris becomes useless after some time. Now we will study about the uses of plaster of Paris. Plaster of Paris is used for making casts for toys and statues. It is also used in dentistry. Plaster of Paris is used for making toys, for cheap ornaments, for decorative materials, and also for blackboard chalks. Plaster of Paris is used as a fireproofing material. Plaster of Paris is used in chemical laboratories in sealing air gaps in apparatus where airtight arrangement is required. Plaster of Paris is used in hospitals for setting fractured bones in a right position and to ensure healing. It keeps the fractured bone straight. This use is based on the fact that when plaster of Paris is mixed with proper quantity of water and is applied around the fractured limbs, then it sets into a hard mass and thus it keeps the bone joint in a fixed position. So plaster of Paris is very important in hospitals for setting fractured bones. Plaster of Paris is also used for smoothing the walls before painting and for making ornamental designs on ceilings and other buildings. Now we will study about water crystallization or hydrated salt. The fixed molecule of water which is present in one formula unit of some salt is known as water of crystallization. This water of crystallization is an essential part for the structure of the salt. It is not free water and so it does not wet the salt. The salts which have water of crystallization is known as hydrated salt. This water of crystallization imparts structure and color to the salt. For example, copper sulfate pentahydrate is blue in color and ferrous sulfate heptahydrate is green in color. Sodium carbonate decahydrate or washing soda is white in color and gypsum or calcium sulfate dihydrate is also white in color. So we can see that water of crystallization imparts color and structure to the salt. Now we will study about the action of heat on water of crystallization. When hydrated salts are heated, then it loses its water of crystallization and forms anhydrous salt. This dehydration of salt is a reversible reaction. So when water is added to this anhydrous salt, it again forms hydrated salt. Now we will see an experiment to prove that water of crystallization imparts color to the salt. If we take few crystals of copper sulfate pentahydrate, which is blue in color, in a dry boiling test tube and heat it in a burner, then we will see that it is giving off its 5 molecules of water of crystallization. Now we have told that this is reversible reaction. We add few drops of water on this anhydrous copper sulfate. It will restore its blue color. So it is a reversible reaction and water of crystallization also imparts structure and color to the salt. And for this reason, anhydrous copper sulfate is used for detecting the presence of moisture in a liquid. Anhydrous copper sulfate has a property that when it comes in contact with water, then it forms copper sulfate pentahydrate and restores its blue color. So a few drops of the liquid which is to be detected is added on anhydrous copper sulfate. The appearance of blue color will indicate the presence of moisture in the liquid. In this way, anhydrous copper sulfate is used to detect the presence of moisture in a liquid. Now there is one very important question from water crystallization. Now let's see the question. How many molecules of water crystallization is present in this hydrated salt? You must also remember the color of the hydrated salts. Copper sulfate crystals. Copper sulfate crystal is also known as CuSO4 5H2O or copper sulfate pentahydrate. So it contains 5 molecules of water crystallization and it is blue in color. Ferrous sulfate. Ferrous sulfate is also known as ferrous sulfate heptahydrate. It contains 7 molecules of water crystallization and it is green in color. Washing soda. Washing soda is also known as sodium carbonate decahydrate and it contains 10 molecules of water crystallization and it is white in color. Gypsum. Gypsum is also known as calcium sulfate dihydrate and it contains 2 molecules of water crystallization and it is also white in color. In our next class of chemistry, we will study about metals and non-metals. Thank you for watching my video, and if you find my video useful, please do like and share my video and subscribe my channel to get the latest update of my videos. And if you have any doubt regarding this chapter, comment below. I will try to answer as early as possible.